Welcome to my channel Learning Electronic Circuits. Here you can learn more about different electronic circuits, its working principles and the construction techniques. Direct current and alternating current sources. Direct current sources. When there is unidirectional flow of electric charge or current, it is called as the direct current. The current flows in a single direction from the positive pole to the negative pole of the source. The flow of electric current may occur through conductors, semiconductors, and in some situations even through insulators and vacuum. Direct current sources are power cells, batteries, solar cells, fuel cells, thermocouple, etc. Direct current can also be obtained by converting the alternating current electronically using rectifiers. Direct current is used to operate electric lamps, electronic equipments, charging batteries, running motors, electrochemical processes, etc. Types of batteries. A single power cell is the primary source of power, and a battery consists of more than one power cell. There are two different types of batteries, the primary cells and the secondary cells. The primary cells or the batteries are for one-time use only, after which it is discarded. The chemical reactions in the battery that produce the charge are not reversible. Examples are C cell, D cell, AA, AAA, button cell, PP3 batteries, etc. The secondary cells or batteries are reusable ones which can be recharged and used again. The chemical reactions in the battery that produce the charge are reversible. Examples are nickel-cadmium, nickel-zinc, lithium-ion, lead-acid, etc. Primary batteries. Primary cells or batteries are those batteries which cannot be recharged. When the charge is lost, the batteries are discarded. The chemical reactions between the electrodes and the electrolyte create a charge accumulation between both the electrodes. Energy produced during the electrochemical reaction is converted into electrical energy. The chemical reactions in the battery use up the chemicals that are needed to generate power when the battery is operated. Battery stops generating power when the chemicals are used up. The different types of primary batteries are zinc, carbon batteries, alkaline batteries, lithium batteries, etc. Primary batteries are made in standard sizes for domestic usage. They are used in flashlights, portable radios, music players, electronic locks, etc. Zinc carbon cell. The zinc carbon cell or the dry cell has zinc that serves as the anode with a negative electrical potential, whereas the manganese dioxide connected to the carbon rod is the cathode with a positive electrical potential. The zinc anode acts as a container which holds the electrolyte, that is an aqueous paste of ammonium chloride mixed with zinc chloride in it. The different zinc carbon batteries are the D cell, C cell, AA, AAA batteries. The current is generated as a result of the electrochemical reaction between the zinc and the manganese dioxide. The zinc carbon cell delivers 1.5 volts and it is the same regardless of the size of the battery. The zinc container oxidizes during its usage over a period of time and its contents leak out, so the battery should not be left in the appliance for a longer duration. Secondary batteries. Secondary cell or rechargeable battery is a type of battery which can be recharged many times during its use before it is discarded. It is also called as an accumulator as it stores energy. These batteries store energy through a reversible electrochemical reaction. It comes with more current carrying capability than primary batteries and it also lasts longer. The more widely used secondary cells are lead acid, nickel cadmium, nickel metal hydride, lithium ion polymer, etc. Rechargeable batteries vary in size and shape, ranging from button cells to megawatt systems. These batteries cost a little more than disposable batteries. It is mostly used in automobile starters, consumer electronics, uninterrupted power supplies, lightweight vehicles, etc. Lead acid battery. Lead acid battery is a secondary battery or a rechargeable battery. It has good current capability and durability and it needs less maintenance. The two electrodes are pure lead on the negative side and lead dioxide on the positive side and has aqueous sulfuric acid as the electrolyte. Electrical energy is produced when the lead acid battery is discharged, releasing energy. Energy is released when water molecules are formed from hydrogen ions of sulfuric acid and oxygen ions of lead dioxide. The positive and negative plates become lead sulfate and sulfuric acid is used up from the electrolyte and becomes water. The two hydrogen ions of the acid react with oxygen ions of lead dioxide, forming strong OH bonds in water. Solar cells. The solar cell is an electrical device that converts energy of light into electricity. This phenomenon is called as the photovoltaic effect, and these cells are known as photovoltaic cells. The electricity is produced irrespective of the source of light, either if it is sunlight or artificial light. The electrical characteristics of the cells, such as voltage, current, or resistance, vary when the light falls on them. When photons from the light hit the solar panel, it is absorbed by semiconductor materials such as doped silicon. The electron-hole pairs are generated by absorption of light. The electrons are excited from their orbitals. The excited electrons travel through the cells when they reach an electrode. The current that flows through the material to neutralize the potential is captured. The solar cells are connected in series and in parallel to provide sufficient amount of voltage and current for regular use. Solar cells are also used for detecting light or electromagnetic radiation near the visible range. Alternating current sources. The electric current that reverses its direction periodically is called as an alternating current. The current may flow through conductors, semiconductor materials, and vacuum. Alternating current is used for power transmission and supply. It is also used in audio and radio transmission that carry sound, images, and data signals. There are also other types of waves such as triangular waves, square waves, etc. used for various applications. Alternating current sources are alternators, dynamos, generators, etc. AC current source is available for domestic use from the grid supply. Alternating current can also be obtained by converting the DC electronically using inverters, UPS, etc. Power generators. A generator is a device that produces electric current by the movement of a conductor or a coil of wire around a magnetic field. It converts mechanical energy that turns the conductor to electrical energy. The electrical supply to the grid is provided by the generators. The two main types of generators are the dynamos and the alternators. A dynamo is a generator that gives pulsating DC, whereas an alternator gives alternating current. A generator consists of two major parts. One, the rotor, which is the rotating part of the device. Two, the stator, which is the stationary part of the device. One of these two parts may generate a magnetic field, and the other has a wound coil where the current is induced due to the movement of the magnetic field. These are the different types of batteries that you can see here. This is a zinc and carbon battery. This is also similarly a dry cell battery. It's not rechargeable. It's a non-rechargeable type of battery. This is mostly used for projects for smaller devices, powering smaller devices like radios. And here you can see the AA battery. This is a rechargeable type of battery. This is a nickel-cadmium type of battery. You can see the size. This is a AA battery. And it's almost similar to the other batteries, and with the exception of the ratings here. 2800 mAh it's shown here. It's a rechargeable battery. The polarity is seen here. It's a positive. The positive polarity is shown here. This is a AAA battery. It's made by another company. You can here see the button cell. It's a smaller type of button cell with a LR44 type of package. Here you can see a lithium ion battery. This battery is used in laptops, and you pack with many of the batteries in series, connected in series and parallel. You'll be able to drive a laptop and many other devices. So this is a lithium ion battery. Lithium, the number is 18650, 5800 mAh, having 3.7 volt lithium ion. This is a battery charger. For rechargeable batteries, we'll be placing this like in this like this in the charger. So smaller batteries can also be put inside. AAA battery can also be inserted like this. Both the AAA and AA batteries can be inserted in this charger. So this is the rechargeable is the battery charger for the rechargeable batteries. We have another charger here. This is a different type of charger. This is particularly used for charging lithium ion battery. This is the lithium ion battery charger. You can insert the battery like this, and we'll be able to charge it on the in the socket like this, wall socket. Two different power banks. These are called power banks. This is used for recharge of devices like smartphone, laptops, and tablets, etc. We have the USB connection here, and it also have a lamp, an emergency lamp that is incorporated with the with this device. This is a power bank device. We have the indicator that shows the amount of charge. This is around 5000 mAh. It's a 5000 mAh type of power bank. You can see the mAh written here. It's written as 5000 mAh. 2 ampere current. This is the current. 2 ampere is the current rating. It gives this 5000 mAh battery. Here you also have the another one. It's 10,000 mAh power bank. This also have it does have two USB connectors, and this shows the indicator. There is a LED indicator there, and it also have a switch here. You can charge this device through the cable. You have the cable here. This is the micro USB cable. You can plug it into this port, and you can use the USB port to connect. You can see a lead acid battery. This is a gel type of battery, mostly used in computer UPS. It's used in computer UPS. You can see the voltage rating, that is shown as 12 volt, 7Ah battery. It's made by Redis. This is a lead acid battery. This have the two poles here, that is the positive and the negative terminals. Shown here, rechargeable sealed lead acid battery. It's a sealed lead acid. It's a sealed lead acid type of battery. So this is the UPS type battery. We also have another type of battery here, mostly used in bikes and maybe in scooters. So we have the terminals. the positive terminal and the negative terminal. It's made by X side. So this is a 12 volt battery. It's a rechargeable type battery. This here it's used. We are using distilled water inside these caps. You can take each of the caps and pour pure distilled water. So we have the level, the maximum and the minimum levels. Outlet here, water overflow outlet. Coming to alternating current, you can see many devices that is producing alternating current. One of the device is the hand cranker. This is the hand cranker type of devices where you can you can produce some energy to power up your power your devices. This is the hand cranking type of device. This is a hand cranker where you can power your USB. This is a USB port where you can plug it and charge your mobile phones. And when you turn like this, the LED lights up. Likewise, you can connect a USB port there, and you can charge your mobile by this hand cranking device. This is run by there is a dynamo generator, a small power generator inside, where you can crank this and generate power from that generator. And using the current and that voltage, you can charge your devices. You can charge your power bank, or you can charge your mobile phone using this device. This is a similar device where you can charge. You can use it as a torch light. This is a hand cranking torch light. You can light up some LEDs here. This is a hand cranking type of torch. So this is the one. This a smaller motor. This motor can also be used as a generator, and it doesn't have any polarity, just have two terminals. We have this motor that it can also be used as a generator. It does give out small amounts of power, smaller amounts of electric power, or EMF, or you can say it's a potential difference or polarity. It can give some amount of EMF when you are rotating this small generator, as it's actually been a motor. It can also be used as a generator. There is a rotor and a stator. The stator is a magnet, it's a permanent magnet, and the rotor is the axle. The axle you can see here, that is a rotor. Rotor will be a set of coils, and there is a set of coils on the rotor side of this motor. So when you turn this axle or the rotor part, it will actually generate electricity in the coils when it's being moved around the magnet. Now we'll just put this in the multimeter range. It just changes from AC 200 volt to maybe to the DC, smaller DC voltage range. It's positioned in the 2 volt range. It's in the 2 volt range here, and we are just connecting the terminals. So we just connect the terminals. There is actually no polarity for this. You can connect anyway, but still I am keeping the polarity here. Now we'll just turn this axle, the rotor part of the motor. Here you can see the voltage that is fluctuating. You can see the fluctuating voltage. When you turn this axle very fast, you can see the voltage going up to 0.5 volt. This is a small computer type of switchboard. There are many sockets seen here. Many sockets that is available, and we also have a switch where when you on the switch the power will be available. This is a alternating current source. This is a line source where we're taking the power in a switchboard. We also have a holder with a bulb, and also connected to a switch here, and there is a plug point. It's a plug pin. Push this off and plug this pin into the socket, and then you can on the switch. Now you can see that the bulb is glowing up. So this is the AC voltage. It is applying to 230 volt AC.